Well, hi, good morning. Thanks so much for joining me here on December 6th. Another kind of warm, kind of rainy day. The weather here has been a little above normal temperature-wise. No snow, just rain falling. So what I want to start undertaking now is the rest of this alignment procedure that's written here. I've already done the very first step, which was tuning up the intermediate frequency stages, transformers, and it didn't require much adjustment. I got a little bit of an improvement there, but not too much. Maybe that suggests what's going to happen with the rest of the alignment. Maybe it's not going to be so bad. The very next thing they're asking to do in this list is to adjust the BFO pitch. And that's done pretty simply by just removing the BFO knob, turning the control behind the knob until you get the pitch to zero out, and then putting the knob back on. That's what that involves. Then, after that, we start at the highest band, 36 megahertz in fact, right at the top of the highest band. We sort of do the high end of the highest band, the low end of the highest band, and we go back and do the high end and the low end, but they're different adjustments. Well, that's quite complicated as compared to many other radios. And also, in here is the infamous rock the tuning cap, a procedure that I tend to not have much luck with. Not always, anyway. Okay, so first thing to do is going to be the pitch control adjustment. So to do that, we need the radio operating, and we're going to need the signal generator sooner or later, right? Do we need it for this stage? I would think so. For this one here. So we have the signal generator attached to the center stator of the tuning cap, 455, no modulation, and we beat it with the control, and then adjust the control down to 0. So I know the IF is at 455. I'm going to need this beast going, and we're going to need the radio operating, and we need this. Actually, we need the we need the signal generator attached to the stator of the center. It's right here. Okie doke. I haven't turned this on yet. Let's switch it on. Volume down. Set on. Look at the meter. It's going to do that on warm up. That's not very good. Don't like that. There we go. A little bit worried. When it's pinned over, you don't know how hard it's pinned over. But it survived. That's something to keep in mind. Maybe I can fiddle. I don't think I want, like this, I believe, is speaker switches. I could probably rearrange the switch so it turns this on and off. That might be a good idea. And is that Santa Claus I hear coming? Who's coming? Who's that I hear? No answer comes in reply. Let's just make sure we're operating here. Here we are. We want to be up on number 4. We want to be tuned up. I think it's at 38. 30. I know you can't see this because of the light. 35, 36, 37, 38. I think that's what it said. That's good enough. Leave this guy warming up. Leave it all warming up for a few minutes. Hey, Peanut. Okay, things are plenty warmed up here, I'm sure. Set this to 455. 455, even though it says 54. Very good. Now we want to do the adjustment of the pitch control. Switch the CW. Wow, it's way out. Okay, we need to take this knob off. Uh-oh. Uh-oh. This takes a little tiny Allen key. Oh. Little teeny tiny one. Okay, so I'm going to have to probably fiddle around here for a while to find a small enough... Oh, this one went in. Holy smokes. Wow, that was tight. Off you come. That's the limit. Uh-oh. What do you do about that now? That's at the limit. Is there another? No. That's an interesting problem. Well, okay, so we're stalled already here with doing this. I really got this done right. Let's put this way out. Yeah, I'm pretty sure. Pretty sure. Well, we'll have to look at the schematic diagram and see about the circuitry and what capacitors are involved in this to cause this oscillation. Copy these guys right here. Okay, quickly to the schematic, Robin. Okay, so I'm totally silent because I'm looking at this 6SC7. Half of it down here and half of it up here is the audio amp. I'm pretty sure this must be the oscillator for it doesn't really show it. Right here it says gimmicks. I thought the gimmick was up here somewhere. I saw the word gimmick. Gimmick is a handmade capacitor just by wrapping wires together, twisting wires together. Okay, let's look at the other schematic for this radio. Where can I find that? Here. This one. Right, it's a different tube. 6J5. And 6SQ7. Still has the 6H6 here, but there's the gimmick. That's where I remember seeing that gimmick. This is feeding back the output of the oscillator up to here, so it's beating against the output of the IF here. Okay, so what radio have I got? I've got this one with the 6J5 in it. What a mix-up. This radio is really mixed up. Okay, because it doesn't have the 80. It's There must have been a series of versions of these radios, and I've only got schematics for a couple of them. There was an article that mentioned run 1, run 2. So I think they're making lots of changes to this. So this is what I've got going. This is what we're adjusting here on the front panel, this coil. And this is the capacitor it's working against, 470, right in parallel with it. Maybe this capacitor is out of whack. A small variation in capacitance might throw this whole coil system out. What else could do it? Well, any of these capacitors can be suspect in influencing the resonance here, I think. This is the big one. This is the main one. 470. Maybe I can find it. And we can change this one out. It's going to be right in parallel with this coil. The coil is center tapped. One end of the coil is grounded. Or one end of the capacitor is grounded. We should find this, and we're going to find this. Okay, let's take a look. Let's take a little look here. Here's the coil. I can see 3 wires coming from it. Let me just get a poker here and I can poke with. Pointer. Coil form. Coil's up in here. 1, 2, 3 terminals. One of these is the center tap, the other one is a ground. So this bare one running here runs to this point, which is then connected to ground right here. So this is the grounded side. This capacitor is running from the coil here to ground. Now this is the 470. Speaker wire just popped off here. Yeah, it's hanging right out there. Okay, so I want to get this guy oscillating. And we're going to fiddle with this suspect capacitor. It's got to be this guy. Anybody else? Watch your finger. This one may have. This is different. This is not part of the resonance circuit directly. It could be both these guys need to go. We'll start with this one. 470. Now, you know what? In all the years I've been doing this, I've never bothered to learn how to read this style of markings on these capacitors. A lot of the colors are faded out here. Now what if I get another capacitor and I just go across here instead of bringing it all the way down to here? So they probably did this because it's easier to install a very large body capacitor. I can probably put it in here. Could I augment this a little bit? If I add a little bit of capacitance here. If this is 470 and I added, say, 20 more temporarily, what would happen? That's interesting. Let's try that. Try that. 20 more. Okay, here's some small capacitors here. Pick one. This is a 20. Happens to be a 20. If we add 20, we'd like the sound to go down. It's going up. No, it went somewhere distant. I didn't get it connected with it. first. Oops. Protecting too much. Adding more doesn't help. What about the other guy? Now the other guy, let me just peek at the schematic again. The other guy is a 47. So this is a 20, so I'm adding a ton here. So it definitely changes it. Pitch went way up, but not as much as you might imagine, because I'm almost doubling the capacitance there. Let's pop this guy out. We'll test him. Actually, I just disconnect one lead and we'll test it in the radio here. Cut the power. When I cut one lead, it's pretty hard to reconnect it. So this is going to be changed anyway. Take it off of here because this is so easy. Okay, what do you test as? We'll try with this tester here. I have a fair bit of faith in this guy. It's supposed to be 470 picofarad, if I remember right. 134. V loss 38%. That doesn't sound good. 134. So when capacitors become leaky, I find the instruments tend to read their capacitance high. I don't think it's really gone high. I don't know how that would happen. So I'll take this guy right out. In fact, we're just going to leave it there. So I'm going to get a 470. We're going to put it in there. Okay, I've tacked in a new 470. I'll just cut the old one out. Looks nice. I'll put that on the leak test. I've tested so few mica capacitors because I believe they're all good. And I seldom have found any that are bad, but you know, I don't have a lot of experience at testing them because I tend to leave them alone. So we got the new one in there. It's just tacked in, but that's going to work. Let's see what happens now. Turn on the radio. Close that meter again. I don't think it's quite pinned. That probably is. There we are. So we check once again, the frequency is still 455, so we beat this down to nothing. I hear another beat frequency in there. Is that from being tuned to something? Oh, there's two tones there. Curious in itself. There we are. We beat down to nothing. We put the knob in with the little red pointer pointing up. I shouldn't really. Oh, there's a white dot. It's paint. Red dot. White dot. Okay, so if we wanted this. Is pointing up. Okay, and what did I do with my nice little Allen key? What did I do with it? No! You haven't. Well, you know what? I have to wash these knobs anyway, so I'm going to leave this off for now. The rest of the knobs got to come off and be cleaned anyway. But there we are. That's the next step in the alignment process. see if we can find a station. Find a station. How are we going to do that? We're going to hook up an antenna. I've still got the signal generator going. Let's get that off. Volume down. Okay. Volume up. Hook up the antenna. Ground side first. Doesn't sound like there's lots there. We're on way up at 30 megahertz. Amateur band. Might be a good spot to try the let's just turn it on. Nothing. Here now. Use this as a fine-tuning control.
Then this is a time because really compete, you cut off the sickness, the mentality, the
CW on.
Most people believe in healing, they die. You have to understand that. But the fact that it has been changed, truly, the word of God. I listen to the enemy tell you.
Well, that's bad for a lot of reasons. Wow. That's bad for a lot of reasons. There's that dirty spot I still haven't dealt with. That was, by the way, where was that signal? According to this, 16,700. Doesn't sound right to me. Any amateur stuff. Way up high in frequency here. Now the solar flux indexes, I checked it yesterday, late last night, just before I went to bed actually. It was 144. 2 days ago it was 107. 144 means lots of shortwave should be happening. So give us a little amateur radio up here. Morse code, anything. No. Okay, we're going to go down a band. That is ham radio stuff. Now you can't see the frequency there because of what's going on with the light. There we are. It's close to 10. So there is a band just above 10 megahertz. Ham band, that's probably what we're listening to. And that's FT8 without that. Oh my gosh. Antenna's not making the best connection here. So I do a lot of FT8 when I'm in the mood. Lots of fun. I won't go into it. But that's not what we're looking for. So we'll go down in frequency. We'll try to find some Morse code down in this area. So now we've passed 10 megahertz. Who's this?
I am not saying the end of the world, but the end of the day. The end of the world is the end of the day.
Can't be sure what's actually... Yes, we can. We can. I think we can be sure what's happening is the BFO is changing frequency here. Nothing down here. Just even the stick getting close. Wow, fun aligning this radio. What else is that sensitive? Oh boy. Oh. I just touched the slug in the coil here. And the radio retuned. Wow. That thing about how you position components and if you move the wires and where the wires are run and all that kind of stuff. Look at how sensitive this stuff is. This is the oscillator section, I'm pretty sure. That's why we're getting all this effect. I don't think we're going to hear the same thing anywhere else here. These are just this would be stages of tuning related to the incoming signal, not the oscillator, not the local oscillator. So super sensitive. Well, as you take a tool, you push it in here to make a change, and you take it out, it's in a different spot than it was. Wow. And so the sensitivity to the... It could be almost anything. Oh my gosh, what did I touch over here? Interesting way to find sensitivities. Maybe you get a set operating, put on the BFO, you start poking around and maybe you hit a resistor whose, when you flex it, its resistance is varying a bit because it's worn out, it's got bad connections inside it. That could be just what exactly is right here. Doesn't want to do it now. I hit something that was really sensitive. No longer sensitive. How did that happen? Nothing down here should do that kind of stuff. going to be up in this area. Switch. Band switch. Doing them right out. This is very interesting, what I'm doing. Very interesting for me. It's showing me just how sensitive everything is. So, I notice the band switch here seems to work fine. Radio's operating. But if I put it a little, just force it a little bit this way, its operation shifts a bit. Force it the other way, it shifts presumably the other way. But you wouldn't know that unless you have this BFO going and you're doing the kind of things I'm doing right now. What that means is you turn to this band, you get it set like this without knowing it, you do the alignment, and when you switch the band switch, now the radio's here. And your alignment is defeated. So that's defeated to some degree. Comes back to the same pitch every time. So what am I doing here? I'm just flexing this whole piece. Just doing it through the switch. I should clean the switch at this point. Okay, let's do that. I'm going to give the switch a little treatment here. I'm going to use the expensive D5 stuff here. Not promoting this in any way. Used to do this with just regular WD-40 all the time. I don't think the switch is particularly dirty. I can never tell if this is actually spraying some liquid out or just gas is coming out of it. Grab something stupid here. Oh, stuff coming out all right. Okay, so we want to get it on the switch parts. We'll do them all. I can see right in the switches, and they look very clean. They have not been acting up, except for the last little bit that we just found. Now, I don't think you can. I don't even know if you can really compensate for this effect, because I think what's happening is when I'm turning this a little bit, I'm applying a stress, mechanical stress. Parts are shifting a little bit. How can you stop that from happening? Drift is the warm-up. Tuned it. I have switched it back on, switched the band back, and there's the station. I mean, it hasn't. Of course, you never notice that if the BFO wasn't on. I mean, you wouldn't notice anything. Sensitivity on the actual switch parts. just a stick. Wow. Surely to goodness, the position of all these parts must be critical in this area. Of course, you would build the radio, and then you do the alignment to compensate for all this stuff. Like this. Don't usually think of these as being conductive. Maybe it is. This is not conductive. Wow. Is there anything you could put in there that wouldn't cause this effect? What have I got? I thought wood would be the greatest. How about thin plastic? It's not my hand until I get up here. If I'm holding a short tool and doing the alignment. All in the oscillator area. Just right in this area here. That indicates something's not right. Big capacitor sitting right here. Hey, that capacitor I took out. We need to put that on the leak test. I think that's going to be the last thing today. I got a late start. Got the BFO kind of under control there. Let's give this guy a test. See if it's leaky. So this is a new area for me. I've somewhat purposefully ignored this. I mean, I'm not looking for more and more work to do on these radios, and I found satisfactory results by ignoring these to a large degree. Occasionally I have found one that has to be it's gone open or something like that, but only occasionally. Okay, 50 volts. You cannot really see the eye there. Let me stand over this way. Okay, now you can kind of see the eye open at the bottom. 50 volts. What do you do? Oh, it stayed closed completely. You know what this is telling me? I've been making a mistake thinking these capacitors are good. Now, to what degree is it leaking? Well, I only have this on 50 volts, and the eye closed completely, didn't open at all. It can't get any worse on this tester. A worse capacitor would test like that. A short tests like that too. So this guy is really quite bad. Uh oh. I've got to. Oh my gosh, my whole philosophy of radio repairs in question now. I mean, look at all these guys in here. They're all over the place. Well, I said I was going to stop. See, there's a big ugly one here, and that other big ugly one up here. I wonder if big and ugly is a good way to tease out the ones that need to be changed. Bigger, bigger capacitor, bigger trouble. Okay, well, I'm done for today anyway. I'm going to think about this. It's not 1, 2, 3, this big one 4. There's probably 2 or 3 more in here I'm not spotting right now. It's not the end of the world to do it. See this one here, and that big guy there. It's maybe 6 or 8 of them. Could be, if I want this thing to perform really well, these have got to go too. Can always do them one at a time, put a test on it, see what the truth is. Because the truth will set me free. Okay, well, thanks a lot for watching, and see what happens tomorrow.